Tonight, you are going to do something your ancient ancestors could not imagine surviving without. You will turn on a stove, or open a microwave, or press a button that heats food to a precise temperature in seconds. You do this without thinking. But the story of how that moment became possible, how fire and food rewired your entire species, is far stranger than you have ever been told. You think cooking is a skill, a cultural practice, something your grandmother passed down, or something you picked up from a video. But cooking is not a skill. It is the reason you exist in the form you do right now. It is the reason your brain is the size it is, the reason you can read these words at all. Let's go back, way back. About 1.9 million years ago, a creature walked across what is now East Africa. It was not quite like anything alive today. It was not fully ape. It was not yet fully human. Its name was Homo Erectus, and something had recently changed about it that paleontologists still argue about. Its brain had grown, its gut had shrunk, its teeth were smaller than those of every ancestor before it. Its legs were longer and more efficient. It looked, in short, more like you. The question is why? For decades, the standard answer was meat. Homo erectus started hunting. Protein flooded the diet. The brain expanded. Simple. But there was a fundamental problem with that story. Chimpanzees eat meat. Baboons eat meat. Their brains did not explode in size the way Homo erectus's did. Meat alone did not explain the leap. Something else was happening. Then a Harvard primatologist named Richard Wrangham proposed something that sounded almost too simple. He said the answer was fire. Not just fire for warmth or protection, fire for cooking. Wrangham's hypothesis, which he laid out in forensic detail in his 2009 book Catching Fire: How Cooking Made Us Human, argued that cooking was not a byproduct of human evolution, it was the engine of it. Here is what Wrangham's research revealed. When you cook food, you do not just change its texture or its flavor, you fundamentally alter its chemistry. Raw starch is tightly coiled and difficult for the body to break apart. Heat unravels it. What was locked becomes available. A raw potato delivers roughly 50% of its calories to your body. A cooked potato delivers nearly 95%. Same potato, almost twice the energy. That is an extraordinary shift. Wrangham calculated that if early hominins began cooking their food regularly, they would have had access to dramatically more calories from the same amount of gathered or hunted material. More calories meant less time foraging. Less time foraging meant more time for everything else. Social bonding, problem solving, rest, play, and crucially, brain growth. The human brain is expensive. It accounts for only about 2% of your body weight, but consumes roughly 20% of your energy at rest. Feeding a brain that large requires serious, consistent caloric input. Raw food diets, Wrangham argued, simply cannot support it. He pointed to modern studies of humans who attempt to live entirely on raw, unprocessed diets. They struggle. They lose weight. Women on strict raw diets frequently lose their menstrual cycles, a signal that the body is rationing energy at the deepest level. The brain you are using right now could not have evolved on raw food. It needed cooking to exist. But the implications go deeper than calories. Your gut shrank. That is the other half of the equation that most people never hear about. Digesting raw plant material is metabolically hard work. It requires a long, heavy, energetically expensive digestive system. Exactly the kind you see in gorillas and other great apes, whose diet is built around raw vegetation. When fire pre-digests food externally, the gut no longer needs to do that work. It can afford to shrink. And when the gut shrinks, the energy that was maintaining it gets freed. That freed energy, Wrangham proposed, was redirected upward, to the brain. Harvard researcher Rachel Carmody, who has spent years testing how much energy different food preparations actually deliver to the body, produced some of the clearest experimental evidence for this shift. Her studies on mice demonstrated that animals fed cooked food gained significantly more weight than those fed the identical number of raw calories. Not because cooked food contains more energy on paper, but because more of that energy is actually accessible after digestion. The metabolic cost of processing raw food is real, measurable, and large. Every time your body digests raw starch or raw protein, it spends energy to extract energy. Cooking eliminates most of that cost before the food ever enters your mouth. You are sitting here, reading, thinking, reasoning, because at some point your ancestors stopped eating raw. Now, you might be wondering where exactly the fire came from. This is where the story gets complicated. The oldest definitive evidence of controlled fire use at a cooking site is roughly 780,000 years old, found at Gesher Benot Yaakov in Israel, burned plant and animal remains alongside stone tools. But Homo erectus appeared almost 1.9 million years ago. That is a gap of more than a million years between the anatomy and the clearest evidence of the technology. Either fire was being used much earlier, and the physical traces have not survived, because fire leaves fragile marks in sediment that erode and disappear, or something else drove the initial changes, and cooking then amplified what was already underway. Wrangham leans toward early fire. He points to charred bones found at Wonderwork Cave in South Africa, dating to around 1 million years ago. He argues that the anatomical changes in Homo erectus, the shrinking gut, the expanding brain, the smaller teeth, the weaker jaw, are so precisely consistent with a cooking adaptation that regular fire use must predate the evidence we currently hold. The absence of evidence, he argues, is not evidence of absence. Flames decay, hearths vanish. The fossil record is very good at preserving bone and very bad at preserving fire. Not everyone agrees. Some paleoanthropologists remain skeptical of the early cooking hypothesis and place the reliable, controlled use of fire considerably later in the timeline. The debate is genuine and ongoing. What is not seriously disputed is the outcome. Cooking changed the human body in ways that no other dietary shift can fully explain. But there is another dimension to this story that almost never gets told. Cooking did not just change your body, it changed how you lived with other people. The French anthropologist Claude Lévi-Strauss wrote in 1964 in The Raw and the Cooked that the transformation of raw food into cooked food was one of the foundational acts of human culture. He was not speaking biologically, he was speaking structurally. Cooking, Lévi-Strauss argued, is one of the primary ways human beings mark themselves as different from animals. The hearth is not just a heat source, it is the center of a social world. Think about what a fire does to a group of people. It pulls them together into a shared space. It extends the usable hours of the day beyond sunset. It requires cooperation. Someone tends the flame, someone hunts, someone gathers. Cooking creates division of labor. It creates dependency between individuals. It creates, in short, the conditions for something that looks like society. There is archaeological evidence that Homo erectus groups slept near fires, that food was carried back to a central location rather than consumed where it was found, that sharing replaced solitary eating as the dominant social behavior around food. These shifts imply trust. They imply planning. They imply the existence of something like a social contract. You bring your food back, you wait, you eat together, and the group is stronger for it. You do versions of this every day, and it feels utterly unremarkable. But it was not. It was revolutionary. The shared meal around a fire was the architectural blueprint for everything that came after it. Language, ritual, family structure, the division of society into roles, the entire scaffolding of human civilization. It started at a hearth, with cooked food, with the simple act of waiting for someone to eat. And your body still carries every mark of that transformation. Your teeth are small, smaller than those of any other great ape, because they no longer needed to grind raw vegetation for hours. Your jaw muscles are weak relative to the size of your skull. Your digestive tract is short. Your stomach acid is among the most potent of any animal on Earth, a chemical environment severe enough to sterilize most bacteria, a feature that some researchers connect to the risks of eating communally prepared food around shared fire sites, where contamination between individuals became a new biological threat. Your face is comparatively flat, because the massive anchor points for the heavy jaw muscles that dominated earlier hominid faces simply were not needed anymore. The face you have is partly the face cooking gave you. Every one of these features is a record. Your skeleton is a document written in the language of fire. Here's what is strange to sit with. You did not choose to be shaped this way. You were born already adapted to cooked food, already dependent on it in a way no other animal is. A chimpanzee placed on a cooked food diet will thrive. But a human placed on a strictly raw diet, over time, begins to struggle in measurable ways. Your digestive system is calibrated to receive food that has already been transformed by heat. You are, in a deep physiological sense, domesticated by fire. Not by agriculture, which came thousands of years later. By the oldest technology your species ever invented. The anthropologist Sarah Brosnan has studied how food-sharing behaviors in primates correlate with social trust and the development of reciprocity. What her research shows is that the impulse to bring food back rather than consume it immediately, to share rather than hoard, is tied to the foundations of cooperation, the social glue that holds primate groups together. Cooking did not just make sharing possible, it made sharing obligatory. The fire was communal, the food prepared at it was communal. The social bonds formed around it were sealed by the shared act of eating. You still feel this. Think about the specific discomfort of eating alone in a public space. Think about what it means when someone cooks a meal for you, not orders it, not buys it, actually prepares it. Think about how a shared dinner changes a relationship in a way that nothing else quite does. That pull toward the table is not a social convention. It is not modern etiquette. It is 1,000,000 years old. It is written into the same biological chapter as your brain and your teeth. Tonight, when you heat your food and sit down to eat, you are doing exactly what your ancestors did around a fire in East Africa nearly 2,000,000 years ago. You are not just consuming calories. You are participating in the ritual that made you what you are. You started cooking food because you had to survive. You are still cooking food for the same reason. Only now, survival looks like gathering around a table instead of a flame. The fire is different. The need is the same. And that moment when heat touches food and something raw becomes something new, that moment has been happening, without interruption, since before your species had a name for it.